Okay guys, so 9.3 is going to be something that might be a little bit new, a little bit confusing for you at first, but we're going to work through it over 2 days. We're going to focus today just on the concept of unit vectors and scaling a vector, and then directions in terms of like theta for angle of a vector. So we're going to work through all of those things today, and then we're going to come back and we're going to go over some of the different applications of vectors in a second day. So let's look at this concept right here. Seems pretty familiar. It's just our unit circle, right? So we're going to be connecting a lot of things that we're doing today. So we're going to be connecting to our unit circle. All of our previous ideas we have with the unit circle are going to show up again today. Surprise, surprise. Unit circle comes back to haunt us. So let's say I'm looking at this right triangle right here, and it has a turn of theta, and this point right here could be represented by the component x1, y1, but this component could also be represented by the cosine of theta and the sine of theta. Oh, there it is, coming back to haunt us. Okay. So let's connect that down here to this. I have some vector, and let's say that he lies along this same direction as this vector up here. So he actually scales out like to right there. We're going to say there's our pink vector, and our pink vector is vector u. Okay. And vector u has a horizontal component of 3 and a vertical component of 4. So you could think of vector u as like a 3, 4 right triangle, and the magnitude of u, or the length of the vector, which would be, if we're thinking about it in terms of right triangles, the length of the hypotenuse would be 3 squared, 4 squared, which would give us 25, and then square root. And we would get that the magnitude of u is simply 5, which we would have expected because I chose these numbers to be a 3, 4, 5 Pythagorean triple right triangle. Okay. But let's imagine that I want to discuss only right triangles that live on the unit circle. Only right triangles or vectors that endpoints end up right there on the unit circle. Well, what would be the magnitude of any vector that ended on the unit circle? Well, the radius of the unit circle is 1, which means that the magnitude of any vector that ended on the circumference of the unit circle, their magnitude must also be 1. So what I'm going to do is talk about those as a unit vector. So all of these blue ones up here would be considered unit vectors. Okay. This, if x, y were the components right here of a vector, then they would also be a unit vector. So a scaled version of a vector where the direction is the same but the magnitude is 1. So unit vectors all have a magnitude of 1, and if I want to compare my original vector u to the unit vector associated with it, I would say that this pink one is u, and if I scale it down so that it only has a magnitude of 1, then that's the unit vector associated with vector u. So same direction, but only 1 long versus 5 long. Now, it doesn't really look like 5, but ignore my scaling problem. Okay. So if I want to talk about the components of u in terms of a unit vector, so for u, the unit vector associated would have to be 1 long, right? So that means that each component of my original vector are going to have to be also scaled down. So if I'm going from a length of 5 to a length of 1, then I'm scaling down. I'm multiplying by 1/5 or dividing by 5. So I'm going to take each component and do the same thing. I'm going to scale it down by a factor that is the length of the magnitude. Okay? So for any vector, we're going to generalize it now. If I have the components of the vector, and I know the magnitude of that vector, then this is the rule that allows us to figure out what the unit vector would be. So for this guy, our vector was 3, 4, and then we scaled it down by the magnitude of the vector, 5, 5. So our unit vector would be 3 over 5, 4 over 5. Or you could write it as 3/5 I plus 4/5 j. All of those things would be correct notations. Looks more like a Y than a V, so I'll make it more like a V. So let's say that now I want to take my vector and I don't want it to be 1. Let's say it started at 5, my original vector. He started at 5 long, but I don't want him to be 5 long anymore. Let's say I want U to be 7 long. Well, anytime I want something to be a certain length, the easiest thing to do is to scale it down and then scale it back up. So let's say it was 5 to begin with, and I want to make it into 1, or I want to make it into 7 at the end. So the magnitude was 5, and I want the magnitude to be 7. So the easiest thing to do is to make it into a 1 and then make it into a 7. So how do I do that? Well, I'm going to multiply by its reciprocal. So like 1/5, I'm going to scale it down by a multiple of 1/5. And then I'm going to scale it up to the size that I want, 7. So what this looks like as a rule is that if I have, let's say I'm going to scale U to be 7 units long, and we're going to call that vector W or something. So W would be the vector U scaled down by however long that vector is, the magnitude of U, and then scaled up by the magnitude I'm interested in. Okay, so this is our original vector, scaled down by the length of the magnitude. That's this step right here. So this step right here goes with this, and then scaling back up to the magnitude I'm interested in would be this term, M. Okay, we're going to do some examples of that here in a little bit. For now, though, just make sure you have that rule in your notes.